So I'm just going to start with this one. We'll do polynomials first, then we'll do rational, then we'll do radical, then we'll do trig. Alrighty?
Alrighty.
Polynomial graphs. Before we even start sketching a polynomials graph, this is something we talked about last year in pre-calc. I don't know if we mentioned it this year, but a polynomials graphs are smooth and continuous. The graph of a polynomial is smooth. Smooth means there aren't any points, like an absolute value has like a corner type point. Continuous means there aren't any interruptions. If you start at the end of a polynomial graph, you can trace the entire graph without lifting up your pencil. There are no discontinuities. A polynomial, you guys, all a polynomial is a bunch of terms like 3x to the fourth plus 5x squared minus 2x. Those are polynomials. We've seen a ton of those, yes? Those are easy to take the derivative of, yes?
Yeah.
They're also pretty easy to graph. That's why we start with these. Okay. So if we have this example here, y equals x to the fourth minus 12x to the third plus 48x squared minus 64x. Are there any vertical asymptotes because of domain restrictions?
No.
There's none of those. Are there any horizontal asymptotes?
No.
In polynomials graphs? We don't have to worry about any asymptotes. Okay, when we get into rational functions and radical functions, those have asymptotes. So we don't have to worry about that. What about x and y-intercepts?
Yes.
Okay. Polynomial functions have x and y-intercepts. Always a y-intercept. Sometimes it doesn't have an x-intercept. So I would start with polynomials. I would start with intercepts. And the easiest one to start with is the y-intercept. How do you find a y-intercept? You let x equals 0. Yeah, so for a y-intercept, you let x equal 0. This is kind of nice. Every single term of the polynomial has x.
0. You win.
So if all the x's equal 0, the y-intercept is 0, 0.
Nah.
Okay. To find an x-intercept, you let y equal 0. So that gives us the equation 0 equals x to the fourth minus 12x to the third plus 48x squared minus 64x. What do you suggest? Factor out. We try to factor out an x. X to the third minus 12x squared plus 48x minus 64. How do we proceed? This is stretching your memory from last year's pre-calc course.
Then I would just do 0 equals x, and then x in the third minus.
So we know x equals 0 is one of them, yeah.
Should I ask him why we don't just
X equals 0 is the one. What about x to the third minus 12x squared
I think you
plus 48x minus 64?
You gotta add 64, divide by 48, whatnot. I don't even like factor by grouping now.
You could try to factor by grouping. If factoring by grouping would fail.
Synthetic division.
Synthetic division is where we need to go, but we have to have a couple of points that are possibilities. You remember the P's and Q's?
Yeah, it's 8, 2.
Okay. The leading coefficient is Q. The constant is P.
Any same pair to the process if we checked out?
Okay.
Coupon Zaid.
Somebody's going to check you out. Plus or minus 1, plus or minus 2, plus or minus 4. These are all the possibilities. Okay? Just for sake of time, we would have tested plus or minus 1. They wouldn't have worked. Plus or minus 2 wouldn't have worked.
How do you know that right off the bat by just looking
Because
at
I have the book in front of me.
Wait, P is the coefficient of the first one?
Yeah.
P is the constant.
Oh, P is coefficient.
Q.
Okay.
Q is the leading coefficient. So anyway, if we're testing for
I'd take all the fun out of synthetic division.
drop down the 1. Does this look familiar at all to anybody?
Yeah, I just.
Then 1 times 4.
1 times 4 is 4, subtract.
And then 4 times
16. 16 times 4.
64.
64, get 0.
So then you plug in x into the squared, x is 16.
So we know x equals 4.
See, that's not.
Okay, and we already knew x equals 0. X equals 4, x equals 0. And now we have this equation, x squared minus 8x plus 16.
Do you use your new P equation from that, or
plus 0x.
like say that was number, say there's one more number, which
Then you go back to your P over Q and keep
you have
testing.
to do your P over Q up there, or can you do your P over Q over
You
new?
could do new P over Q.
Yeah.
It would give you less numbers.
I feel like that would make it.
Doesn't this factor
Yes.
into x minus 4, x minus 4? What does that mean?
That's a, what's it called?
It's got multiplicity of
Up to
2.
more than 2 because we had one up here as well.
There's 4.
X equals 4, x equals 4, x equals 4. It has a multiplicity of 3.
Oh my gosh, yeah.
So anyway, x equals 4 and x equals 0. Those are the x-intercepts. So we have 0, 0, which we already knew because that was our y-intercept.
Yeah.
And then we have 4, 0. So, those are the intercepts.
It's got an odd multiplicity. It's
Gonna bounce.
Cross, odd multiplicity crosses.
Gosh dang it.
So the way I remember it is like if you have 2 coming up, that's an even number.
Okay. The next thing is to do the first derivative to find extreme. You need to do the first derivative to find the relative minimums and maximums. So what was the original function next to the 4? So the original function was x to the 4th minus 12x to the 3rd plus 48x squared minus 64. Now we take the first derivative, f prime of x well, come on now, this is a polynomial function. This is easy. 4x to the 3rd oh boy, 48 times 2
Oh geez, nobody cares. No.
96 x
That's it.
oh, is it negative 64x? Oh, negative 64x. So then it's minus 64.
Wow. That's not sweet.
Does something divide all of these?
Yeah, 4 does.
8.
So we can take out a 4, and that's x to the 3rd minus
You should pull it. Oh, we can't pull
9x squared plus,
2. That's
what is it, 24? 24x minus 16. Okay, and then we set that equal to 0.
no let's do 0 over the x cubed.
The 4 is kind of useless. Divide by 4 on both sides, and the 4 just disappears.
Why can't we just do 0 cubed, 0 squared?
0.
Just get rid of it.
Because we don't know what x is. If x does turn out to be 0,
Dang it.
we'd be dividing by
I've
0.
always wanted to do that.
Find the easy way out here.
So how do we solve this equation? X to the third minus 9x squared plus 24x minus 16. You guys know what to do. Synthetic division. We got to have our p's and q's. Maybe plus or minus 1, 2, 4, 8, and 16. That's the p over q.
Okay, what's doing Q? So it's just dividing.
P are the factors of 16. Q are the factors of the leading coefficient, which is 1. So dividing by 1 just means that these are the P over Q numbers. Do you have a question? Okay. So if we test 1, I think we're going to get lucky. Drop down the 1. Multiply. Look at that.
Oh,
We must be living right.
Yeah, we are.
So we know that x equals 1 is a critical number, and then we're left with the reduced polynomial of x squared minus 8x plus, and that's just x minus 4 squared. So that gives us another critical value of x equals 4. No, we were doing
now we're going to take this
something a little different.
fourth derivative of that equation.
Yeah, that seems reasonable.
Confused on? We're just solving a polynomial equation that we did last year in pre-calc. All right.
My teacher thought he taught it to us.
That's unfortunate.
Where do you plug? So you
I
plug
had
one of
best
the X
pre-calculation.
used to try and done that?
Hold on. Shh. We know that x equals 1 works because we got a remainder of 0. So x equals 1 has to be a 0 of this polynomial. Okay? And then we were left with this reduced polynomial that just factors into that. And if you set that equal to 0, you're going to get x equals 4. So those are your two critical numbers.
Alright. And then,
Why don't we do
So are we testing for increasing?
We're testing for the extrema. The first derivative test. Why would we want to have... Well, first of all, let's just go back and remember how we did this in pre-calc. In pre-calc, what you really needed to know were the X-intercepts and the Y-intercepts and the end behavior. If this is a 4th degree... Was it a 4th degree? Yeah, it's 4th degree polynomial, so what would the end behavior be? Left side's up, right side's up. Okay, and then as the graph approaches that X-intercept, does it bounce across?
cross.
How do we know?
That's a single multiplicity.
Yeah, that's a single multiplicity, so it crosses through. And then it may have a couple of turning points here, and then what happens there?
Cross again.
Crosses again. So in pre-calc, you didn't have a real good idea of where these relative minimums and maximums might have been. You just kind of estimated. Okay?
Now we'll know.
But in calculus, we can take a first derivative and find out exactly where these are. Do you guys follow?
Yeah.
That's legit.
So
Okay.
everything's combining, becoming something.
Now, it doesn't say that we can't get an idea of what it says, or what it looks like on a calculator. Let's at least get an idea of what this even looks like. Should have started with this.
Woo.
Which calculator's out?
You learn the half. You learn multiplication. Then you learn about fractions. Oh wow. We hit those for
Then we learn about an acre.
and you learn about x's.
Ooh, calculator, where'd you go? So,
Use decimals.
x to the 4th minus 12x
You know how to fix
to the 3rd plus 48x squared minus 64x.
And then like carrot just goes right there.
Yeah, mine does the same. I think you just have to update it.
You have to update it.
How do I do that?
I can do that for you.
What's on that?
Update your software. So I've just got a normal standard viewing window from 0 to 10, or from -10 to 10 and -10 to 10. Do you see what's missing? You guys got to focus here. This is my picture of the graph. What don't I see that I should be seeing? There's a minimum value down here that I'm not seeing, so I need to go to my window and set my Y minimum to be a little bit less than -10. I'm going to go -35. See if that's enough. So there's a relative minimum down there. What does it look like the corresponding X value is? 1, and didn't we have that as one of our critical numbers?
So because negative, positive, positive.
So anyway, we know that the end behavior of a 4 to be polynomial is up and up. Okay. How do we know this is going to be a relative min or a relative max?
When you gotta plug them back into the derivative equation.
Plug it back in. Okay. To the derivative, because we want to figure out where it's increasing and decreasing. Okay. So it just, you guys can do all this. I know you know how to do this. What would happen here is we get negative plus plus. If you were to plug that in and test it, you get negative plus plus.
No, because Reddit wants that it's going to start square out and then it goes up.
Because the other point, that's where, this just shows where the slope is 0.
So that means we have a relative minimum right there. What is this?
That's
It's not an extreme right there. Okay? We have a relative min
points just there for the right.
at x equals 1. How do you find out what the y value is? You plug it back into the original. Okay, it would be 1 comma negative 27. If you plug this back into the original function.
You still have to do that all in his head.
No, I got the book out. I'm just trying to save time. You guys can plug in a 1 and get negative 27. That's not a hard thing to do. I'm not too concerned about that. Okay, that's a minimum. So we know at 1, negative 27, way down here, negative 27, we have a relative minimum. Okay.
Wow.
Now what happens?
It parabola.
Does it just go straight up?
Well, there's a chance it
It's
could.
not a slope of 0 right there.
It has to have
Yeah,
Got a crap.
a little bit of a curve there and a little bit of a curve there.
it's parabola.
Okay, because at x equals 4, it was a critical number. It didn't turn out to be extreme. But what happens here is it changes concavity. Okay, that would actually be the next part, as you do the second derivative to find concavity. Okay,
You can clearly see it.
to find the inflection points. How would you describe this part of the graph right here? Okay, it's a smiley face, concave up. But then this, I'm going to do it in a different color. This piece right here,
Concave down.
that's concave down. And then this piece right here, that's another concave up. So what you're going to have to find are the inflection points where it switches concavity. How do you find the inflection points? Second derivative, you said the second derivative equal to 0. Are we good at polynomials? Okay, that took a lot longer than I thought. Let's move on to rationals.
Yeah. That was really not my thing.
Okay, we're actually just going to do this like you had learned last year. There's really no difference than what you learned last year. You just got to remember what you learned last year. So recall rational functions have vertical, whoa, if I can spell, vertical asymptotes at domain restrictions. Well, actually, I need to clarify that. This is way back from chapter 1 that you might recall. Discontinuities aren't always vertical asymptotes. Do you remember another type of discontinuity? Or it could be
Jumps.
a hole. So you can have a vertical asymptote, or you can have a hole at domain restrictions. It's a hole if it's a removable discontinuity. They have horizontal asymptotes. This is how I taught it, at least in my pre-calc class. First, you find the vertical asymptote by domain restriction. Second, you find the horizontal asymptote by comparing the degree. Remember we talked about this last week, the degree of the numerator compared to the denominator. Sound familiar?
Yeah.
Okay, the next thing we're to find intercepts. And the last thing was to sketch the graph after you have all of that. Vertical asymptotes, horizontal asymptotes, find the intercepts, and then try to fit in the graph. So let's do one of those. This is one of those things from last year that it was something you learned it probably well enough to pass the test, and then after that, it was gone.
Sure.
Am I right?
Yes, sir. That's how all math is.
And I'm not blaming you for it. If it's something you're not using on a daily basis, it is going to probably
That's how you get the
not be remembered. Here we go. 2 times x squared minus 9 over x squared minus 4. We're going to sketch that.
Yeah. All right. Shoot.
And let's just use this here kind of as our guide. Vertical asymptotes, horizontal asymptotes, intercepts, and then trying to fit the graph in between all those things. First thing I actually would do is factor here.
You killed me, kid. You killed me.
So we have difference of squares on the top and bottom. So we are going to have discontinuities because x can't be 2 or negative 2, but we have to decide if they're removable. Removable means you can factor them out and cancel them. That would represent a hole. If they're not removable, that's a vertical asymptote. So what do we have? These are non-removable. So vertical asymptotes at 2 and negative 2. Vertical asymptotes are from domain restrictions if they're non-removable. If they're removable, they're holes. Next thing, and this is just one of these matters of memory, finding horizontal asymptotes isn't that hard to do, but you have to remember exactly the right case you're in. Horizontal asymptotes is a comparison of the numerator's degree compared to the denominator's degree. If they're the same degree, you divide the leading coefficients. These are the same degree, yes?
Yeah.
So you divide the leading coefficients.
What's that, 2?
2 divided by 1 is 2. Okay, so we've got all the asymptotes, vertical and horizontal. The next thing is to find intercepts. Oh, true or false? A graph can cross a vertical asymptote. True or false? Okay, what about a horizontal asymptote? True or false? A graph? It is true. Okay, it has to approach it as x approaches infinity, but near the origin, a graph can kind of go up and down, and then finally it will level off and approach the asymptote as x approaches infinity, the horizontal asymptote. Anyway, intercepts. Let's find the y-intercept. That's always the easiest one, I think, to start with, because you just let x equal 0.
Yeah.
All of the x's equal 0. So in the numerator, 0 squared minus 9. Negative 9 times 2. Negative 18. 0 squared minus 4. Negative 4, so that's 9 halves. So the y-intercept is 0, comma 4.5. 1, 2, 3, 4, 4.5. There you are, right up there. This you may not remember. It's one of these things that it's good if you can remember it because it makes it a lot easier. How do you find x-intercepts of a rational function? Other way around. Yeah, and here's why. It's one thing to remember what to do, but it's another thing to understand why. To find an x-intercept, don't you let y equal 0?
Yeah.
So that just means f of x is going to equal 0. When is a fraction ever going to equal 0? And the top is equal to 0. That's why the shortcut here is if you want to find the x-intercepts, you just set the top equal to 0 and solve that equation there. Or this one rather. This one would be easier to solve in factored form. When is that ever going to equal 0? Positive and negative 3. So we have an x-intercept at 3, an x-intercept at negative 3. And it kind of depends on whose class you were in last year for pre-calc. I wasn't so concerned about, well, the accuracy of where your points are rather than where the pieces of the graph are. Here's what I mean. See if this makes any sense. Let's start on the furthest to the right here. Your only options for where the graph can be are either up here or down here like that. Those are only two options. You can't have both because then it wouldn't be a function. It wouldn't pass a vertical line test. But because we have an x-intercept right here already.
We need that to go to the auditorium at this time.
Sweet.
I was going to go, Mr. Hodge.
Anyway, do you guys understand what I'm saying?
Yeah.
Because there's an x-intercept down here already, we know that there's not going to be a piece up there. The piece of the graph has to be down here like that. Yeah? Now we can use a similar argument over here. Because we already know that there's an x-intercept right here, what does that mean about the graph on the left side of this vertical asymptote? It needs to cross there. Okay? Now what about the middle? You guys, a lot of this is just your thinking skills, your critical thinking skills. Is this a possibility? Like that?
No.
Why is that not a possibility?
There's an X.
There's no x-intercept there. That can't happen.
So it's got to be like a...
What about that? That can't happen either. There's no x. There aren't any x-intercepts between -2 and +2.
Upward parabola.
So it has to be.
An upward
We got to
parabola.
find, they might like kind of...
We don't care if it does that. I try not to see that. You could try that.
I'll be trying to run.
And so how do we know? That actually is a pretty good point. How do we know that the graph doesn't come up like that? Maybe it comes up like, maybe it does something funky like that. How do we know for sure? We could test points. Okay, on either side of 0, we could do 1 and -1. Okay, let's not take too long with this. If x is 1,
It's
1 squared minus 9,
negative 8.
-8 times 2,
Negative 16.
-16. 1 squared minus 4, so 16/3. That's 4. That's 5 actually. That's 5 point something. So 1 is 5 point something.
I just had to ask the question, Gabe.
What about a -1? Wouldn't -1 be the exact same thing?
Yeah.
So -1 would be 5 point something. So it is parabolic in shape, I guess you could call it.
Parabolical.
Okay. I'm not going to expect anything more on a test than what we just did here. Okay? You find the vertical asymptotes, the horizontal asymptotes, the intercept, and you try to fit the graph in, just kind of reasoning your way through it. You guys follow? Okay? We're going to have to pick this up next time, I'm afraid. Dang it.